Hello everyone, in this video we are going to discuss the solution for squares or sorted array. So let's see how we can solve this problem. Okay, then let's discuss our question first, then we will move on to its solution. Okay, so we have been given a integer array called nums. Let's say that this is my array. Okay, which is sorted in non-decreasing order or just increasing order. Okay, and what we need to do is we need to create array of square for each number in sorted non-decreasing order. So simply what we need to do is square all these number present in this array. Okay, so for example, minus 25 square is 25. Minus 5 square is 25, minus 4 square is 16, minus 3 square is 9, 0 square is 0, 2 square is 4. We need to create an answer array in which all these squares are in sorted order. So it should look like this: 0, 4, 9, 16 and 25. Okay, and we should return this answer array. So this is what we need to do in this question. As I have done here, it is very simple. We can just create a answer array in which we store the square of all the elements and then we just sort it. Isn't it very easy? But if you will look at its time complexity, first what you need to do is square all the numbers and then add them to the answer, and then you need to sort this answer array. Okay, so squaring for each of the number and then adding to the this array will take some O of n time, and sorting will take probably n log n time, and overall complexity for this operation for converting into square array, then sorting that array will take time complexity of O of big O of n log n. But if you have read the constraint for this program very carefully, you will notice that we need to solve this problem in O of n time, not n log n time. So we can't do sorting. If we will do sorting, then it will take much more than our given constraint, and we can't change the constraints here. Okay, so let's remove all this. Okay, now this was my answer array which was sorted. Okay, let's assume something, that this is my answer array and it is filled. I know it is not filled, it's empty, but let's suppose it is filled in the way that we needed, in sorted non-decreasing order with square of each number. Okay, okay, so if I will pick this block, this element, okay, if I will say that I am choosing this element, will it be the largest element for this? This will be the largest element for this answer array. Yes, it will be the largest element because that is sorted in non-decreasing order or simply increasing order. Okay, now this is my largest, and if I will ask you, if this is the largest element for this answer array, then how can this answer this largest element is made? It must be made from either this element or this element, most negative number or most positive number. Now think about it carefully what I have just said. This largest number that I have in answer array will be created by either the most positive number or most negative number. Just think. Okay, So maybe you haven't able to visualize it. So let's take a guess. Let's take examples. So in here we have -5 and -2. Okay, this is my most positive, sorry, most negative, and this is my most positive. Okay, if I will square them, I will get 25 and 4. Obviously 25 is bigger and 25 will come here. Now this was my most negative or most positive. If I will say no, I was wrong and this could be the largest, this number square will be 16, this is 9, and this is 0. So obviously what I have just said, that either the most positive number or the most positive number or most negative number is going to create the largest number in the answer array. Okay, so let's take one more example. Let's say -9 and 25. Okay, these are the most negative number and most positive number. If we will square them, we got 81 and we got 625. Okay, so which is bigger? 625 is bigger, so largest element will be 625. Oh, that's some pattern here, right? If I'm able to fill this box by comparing these two numbers, then I am very sure that I will be able to fill all these number by comparing these comparison. First I will do with these two, then I will do with these two, then I will do with these two, like that. Okay, so let's take an example to apply this approach. So let's name this I and J, and let's keep a pointer for our answer array as well called K. Okay, so I will try to compare square of -5 and 2. Okay, so let's name them V1 and V2. V1 will represent square of the ith element and V2 will represent square of jth element. Let's name it square of I and square of jth. This is what V1 and V2 are representing. Okay, so let's start our comparison. I -5 square will be 25 and 2 square will be 4. Which one is bigger? 25 is bigger, so 25 will be placed here. Okay, now 25 has been chosen already, so I will shift to right. Okay, now -4 square and 2 square will be competing against each other. -16 and 4. 16 is bigger, 16 will be placed here. Oh, we forgot to move our K. K was here. Okay, now -4 has won, so I will move again. Now if I have moved I or even J, K is always moving when it is filled. Okay, just remember to do that. Okay, now -3 square, which is 9, 2 square, which is 4. 9 will be chosen and 9 will be filled here with at the area that is indicated by my K pointer. K will move, I will move also. Now 0 square will be 0 and 2 square is 4. 4 will be chosen and 4 will be filled in the answer. Now J will move from 2 to 0. Okay, it will move toward left. I is moved to our right and J is moved to our left. Okay, now this will be my final comparison. 0 and 0. Who will win? 0 will win. So 0 will be placed here. I forgot to move this keywords here, and our comparison is done. And now for next loop, J will move here, and if we will try to do this comparison now, it is not possible because we have already made comparison for I and J. And now if you will try to look at here how many comparison we actually did, you can see this is my first comparison, second comparison, third comparison, fourth comparison, and fifth comparison. After my fifth comparison, my answer array was completely filled. And if you look carefully, you will find size of this array is nothing but 5. So I can clearly see that this loop has run for big O of n. Okay, now after this my answer array will be filled. Okay, now this is how we are going to do this. But let's suppose that you have all the positive integers. Okay, let's say you have 0, 1, 2, 3, 4. In this case, you don't actually need to compare like this. You can just do, what you can do is simply run your loop for this left to right and fill your answer array with the square of each element, because that is already sorted. It won't be very difficult to do that. Okay, but this will work only when you have only positive integer. In the constraint, you have to look very carefully. Okay, so we are done with the approach. Now let's try to implement it. Alright, then let's code this now. So first thing we need is our answer array, which we are going to fill int answer and new int n. Let's declare n as nums.length. Int n equals nums.length. Okay, int I equal to 0 and int j equal to n minus 1 and k equals to n minus 1. Now remember, I may have used n minus 1 for k and n minus 1 for j because the size of nums array and the size of my answer array are same. Okay, here you can see I have put the size of my answer array as n. Also, one more thing you need to note is I and j are the pointers that are working on nums array, not the answer array. Only k pointer is working on answer array. Okay, so now it is very simple. While loop for I less than equal to j, and now in this while loop what I need to do is calculate value 1, which was representing the square of my ith element. So nums I squared, nums I into nums I. Alright, now we have first value. Now we need to create second value, which was square of my jth element, and that's it. Now we have square of our second element or jth element. Now we just need to compare which one is bigger, and the bigger element, either v1 or v2, is going to be placed in my answer array first or in the last. So let's put it, if v1 is greater than v2, then it means at index k v1 should be present. That's it. And v1 was representing my ith element, so I will move towards right. For that, I plus plus, else it means v2 is greater than v1. So answer, array's kth element will be equal to v2, and j will move toward left, so j minus minus, and k is always moving towards left, so k minus minus. And that's it, we are done. Now we need to return our answer. That's it. So let's run it now. Okay, I made a syntax error at 9. Okay, semicolon, comma, and this will run now. Okay, so it is accepted for a sample test case. Let's submit it. Okay, it's taking some time. All right, so we got a successful submission, which means our code is completely correct and it is running in the given constraint for the program. Now you can clearly see why we were doing this kind of work, because it was running in O of n time. Although we can actually do it n log n time by simply sorting the squared array that we have got, but it won't be most efficient solution for this. So that's why we did this kind of work. We used some pointers on the array and tried to fill it according to it. So that's all for the solution of the square of sorted array problem, and I hope that you have understood the solution very well. If you haven't, I will just recommend you to watch the dry run again of this problem, and I'm sure that you will be able to understand that by then. Okay, so that's all for this video, and I will see you in the next video with a new question. So goodbye for then.